In the plate with a hole under plane stress, find deformed shape of the hole and determine the maximum stress distribution along A to B, and the Young's modulus is equal to 210 gigapascal and thickness equal to 1 mm. Poisson's ratio is equal to 0.3 and diameter of the circle is equal to 10 mm. Analysis assumption, plane stress with thickness is used. So the geometry is given, it's a rectangular plate with a circular hole and it is subjected to a force of 200 Newton at its edge. So in this problem we have to solve and find the deformed shape and then maximum stress distribution along the AB section. So we can use the ANSYS software. So go to preprocessor, element type, order delete, add solid quad 4 node 182 element. So check the problem statement. So here they are mentioned the plane stress with the thickness is used and also they are given the thickness equal to 1 mm. In plane stress condition the thickness is negligible, but here we are going to include the thickness so that go to the options in the element types, under element types. So in the element behavior the default behavior is plane stress condition. Now we should include the thickness so that we can select plane stress with the thickness. Then click OK and close. Next we are going to select the real constant, add edit delete, add. By using this option we can include the thickness that is 1 mm. Then click OK. And go to material properties, material models, structural, linear, elastic, isotropic. So check the problem statement. So in the problem statement it is mentioned the Young's modulus is 210 gigapascal, but the geometry is given using mm, so that we have to follow the unit mm and Newton. So it is converted into 210 gigapascal into Newton per mm square. So 2.1 into E5, 10 to the power of 5, and then the Poisson's ratio. Check the problem statement. The Poisson's ratio is 0.3, so it is 0.3. Then click OK. So now next we are going to model the plate. So create areas. So first check the problem statement. So in the problem statement the model is a symmetrical model. So symmetrical means so both geometrical symmetry as well as the boundary conditions also symmetrical boundary conditions. So in the geometrical it is symmetrical about both x-axis and y-axis, so that I am going to model the quarter portion of this geometry. So now the length of this quarter portion is there is 60 mm and then height is the length is 30 mm and height is 20 mm. So create areas rectangle by two corners. The origin is 0, 0 and 30 mm width and 20 mm height. Then next create the circle. Circle, solid circle, the origin is 0 and 0. The diameter of the circle, so in the problem statement they are given 10 mm, but here we should enter the radius, so that is 5 mm, and then click OK. Now I am going to subtract the circle from the rectangle so that we can get the hole. So I am choosing Boolean operation, so that select operate Booleans, subtract areas, select the base area is a rectangle, apply, select the area to be subtracted is a circle. So now you will be getting the geometry. So next meshing, mesh tool, smart size. So check the size, that is 3, mesh, pick all. So now I'm going to apply the boundary condition. So it is a symmetrical model, so that define loads, apply structural. So here displacement, under displacement the symmetry boundary condition option, select the symmetry boundary condition option on lines, It is symmetrical about the vertical axis, so select the vertical line, and it is symmetrical about the horizontal axis, that is x-axis, so select the horizontal line. Then click OK. So next, force or moment. So here the 200 Newton force is applied at the edge, but in the edge here we should consider thickness, so that it is not a force, nodal forces. So here we are going to apply the pressure load. So the pressure load, how to convert the nodal force into pressure load? So what is pressure? Pressure is equal to, there is force by area. So now this force equal to pressure into area, so that the pressure is equal to force by area. So here the force is 200 Newton force is applied at this edge. This will be converted into pressure. So pressure is equal to force by area. There is 2000 Newton divided by, what is the area of cross section? There is 40 into 1 mm. Thickness is 1 mm. So 2000 divided by 40, which is equal to 50 Newton per mm square. That means 50 megapascal pressure is applied at this edge. This pressure is applied opposite direction, because pressure is applied towards the geometry. Here the pressure is tensile, so it is acting in the opposite direction. So now we are going to apply the 50 megapascal pressure into this geometry. So apply pressure on lines. So select the right edge, apply here the 50 megapascal tensile, so that minus 50, then click OK. So now the preprocessor is completed. Go to solution, solve current TLS, then click OK. The solution is done. So go to general post processor. So take the problem statement. We can review the results. So the question is to find the deformed shape of the hole and determine the maximum stress distribution. So go to plot results. Under plot results, select the contour plot, nodal solution, and displacement vector sum. So this is the deformation of the hole. And then element solution, stress and von Mises stress, like the von Mises stress. So it is a stress distribution. So it's a quarter portion of the model. So this model will be expanded, so that we'll be getting the full model. So by using plot control option, so hard cop plot controls, style, go to style, and the symmetry expansion, periodic or cyclic symmetry. So this quarter portion will be expanded. That is 1 by 4 dihedral symmetry, and click OK. You will be getting the stress distribution for the entire model. Okay. So now you can plot this model, both deformation as well as the stress distribution is. So go to plot controls, so and then capture image. So before that, you can change the background by using style options, colors, and the reverse video. So now the background will be a white background. Now you can capture this image and save it. We can print. Okay. Similarly, you can print the deflection, this deformation, by using plot control, capture image. Okay. Thank you.